looks like you could use some help here.
Yeah, I do.
So what's happening?
I'm trying to run this test, but it doesn't work.
Okay, let me see how you do it.
Let me just run it again.
Wait, are you running the main application?
I think so.
There's supposed to be a test here, a unit test.
It kind of made sense while I was doing it, but I gotta refactor it again.
Man, this method is gigantic. Wait, let me show you something.
Ah, good one.
Nice.
Today we're going to be talking about the skills that are relevant for a senior Java developer. So what we have here are things that are not really required to be known by a junior developer, but as a senior developer you might want to be exposed to these topics. So as we've seen previously, these are the basic things that you need to know as a Java developer. And for the advanced developer, I added some hot topics here. One of those topics is asynchronous programming. By learning asynchronous programming, you get an extra power, let's say, that allows you to write software that doesn't have to wait for certain events to occur. In terms of asynchronous programming, we are talking about things like futures, callbacks, and reactive programming as well can be seen as a form of asynchronous programming. And this form of programming was created to allow systems to scale. Basically, when you have a very advanced system with a lot of requests, you want to try to optimize that system in order to be more efficient. Asynchronous programming allows to do that by relieving that pressure from the application that is actually executing that part of the code. So basically, asynchronous programming is a paradigm that allows the application to continue processing without having to wait for an event to occur. You can think of that as, for example, input-output operation into a database where you would have to wait for the database to return with the data. In the case of asynchronous programming, you would fire the request to the database and the database will notify you once the processing is over. So you don't overload your system, and this can be applied on databases, HTTP servers, and the next topic that I added here is the Java virtual machine. The Java virtual machine is the core of every Java application, of course, and understanding the Java virtual machine is really a task for a senior developer to do, because by understanding the Java virtual machine, you are able to optimize it depending on the tasks at hand. Things like memory management, garbage collection, understanding the heap, understanding the stack, and also how a .class file becomes the bytecode and it gets executed on the hardware. It is something relevant to at least grasp as a senior developer. Next topic here we have functional programming. After Java 8 was created, Java decided to add a little bit of a touch of functional programming in it. And we can see that in the forms of lambdas, and you also have the functional interfaces that were introduced in Java 8, and of course the Stream API, which is a new way of dealing with collections. So functional programming, I would say that probably if you're a beginner Java developer today, you would learn out of the box, but for more seasoned developers, functional programming is something new. Next is multi-threading, very hot topic in Java, not used a lot in your day-to-day life, but it is very important because multi-threading is all about concurrency and executing your application in parallel. and splitting the execution of your application as well. Many frameworks such as Spring, they already abstract multi-threading for you in their HTTP servers or in parts of the framework. But sometimes a senior developer has a task at hand and he needs to actually implement multi-threaded code. So you do that by using task schedulers, thread pools, and things like that. Down here I have servlets and HTTP filters. Basically this is network programming, and when you're a senior developer it's good to understand how filters, interceptors, and pretty much the whole servlet API from Java, how it works, because this will make it more clear on the networking side of Java. With that said, these are the advanced topics for a senior Java developer to know. Let's talk a little bit about messaging now. So in order to achieve asynchronous programming, as discussed previously here on the Java level, you can use messaging. Messaging is a programming technique, let's say, of creating asynchronous applications. A messaging system sits in between two different applications, and one application will publish messages to this system, and other applications are allowed to subscribe to that messaging bus. This is known as the publish-subscribe model. And Kafka is one implementation of that system. It is the most popular publish-subscribe system. It's extremely scalable, robust, and it's used by tons of organizations in the world. So as a senior developer, it's really important to understand how Kafka works, maybe even how Kafka streams work, because probably you're going to be working with that. Another form of messaging systems are queues. For example, RabbitMQ or ZeroMQ or ActiveMQ. So you have a lot of options here for queuing systems. They're essentially messaging systems similar to Kafka, but each of these systems, they have subtle differences. But the main thing to understand here is that messaging systems allow your application to be asynchronous. Now let's go ahead and talk about advanced topics in databases. When we talk about databases, it's really important to understand how to optimize your queries. Because you see, when the database grows and the data on the tables grows as well, with time, your database might become slow and inefficient. So query optimization is the technique of going through your queries and trying to optimize them to have a better performance. One of the things that you can do to achieve that is the use of indexes. Indexes are basically ways of creating extremely efficient ways of finding data on a certain column of your database. So understanding how to create and use indexes, it is important as a senior Java developer. Of course, you have the next topic here is partitioning. So when I talk about partitioning, I am talking about dividing your database to be able to query it faster. Sometimes when a database grows too much, a single table is not enough to store all the data and be efficient to find it. One way to approach that problem is to partition the data in several tables. For example, imagine a system that generates a lot of data and it generates this data in a linear way. So you could break up this data in years, for example. Instead of having all of the data in one table for all the years, you could break the data per year in different tables. This would be a simple form of partitioning. Of course, we cannot forget about NoSQL. So NoSQL databases. As the name suggests, NoSQL is the opposite of SQL. SQL is the structured query language that is used in relational databases. When I talk about relational databases, I mean databases that have tables. NoSQL databases, they don't have tables, they use documents instead, and they store JSON files in there. And NoSQL can be extremely efficient and fast for certain applications. So understanding how NoSQL works can be a very good tool in your programming toolbox. Next, we're gonna talk a little bit about cloud and Kubernetes. So basically, Kubernetes is a container management tool created by Google that allows you to have a whole system running inside of it in the form of pods. Let me explain a little bit about that. As we discussed in the previous video about Docker, Docker allows you to create containers, which are small blocks of executable software with your application in it. Kubernetes goes a level beyond and allows you to manage all of those containers together to create a bigger system. Kubernetes is obviously cloud native. That means that it allows you to run whole fully fledged systems on the cloud. It has integrations with CI/CD tools, which are continuous integration and delivery tooling. For example, like Azure DevOps or Jenkins. Also, it's important to understand how to manage your secrets and configurations based on different environments. I added here pods, which are the minimal unit of work in Kubernetes. So basically a pod is nothing but a box that has a Docker image inside of it. A system running on Kubernetes is usually composed of different pods that are talking to each other. And Kubernetes allows you to specify declaratively how you want your system to behave and how you want your system to scale. So this is also a very cool feature of Kubernetes, is you can tell him that I want my system running with 4 pods as a minimum and 10 pods as a maximum, and you can scale the system up and down based on certain metrics. Of course, deployment files are the way you tell Kubernetes on how your application is going to be deployed in the cluster. And with these concepts here, you will be able to understand Kubernetes and have it also on your toolbox. Since we're talking about Kubernetes, we need to talk a little bit about cloud computing. So in the modern day of programming and computing, big players such as Google, Amazon, and Microsoft, they have joined the arena to provide you with their services in the cloud. So basically what that means is that now you can take your application and run it on someone else's infrastructure. So Google Cloud Platform, Amazon Web Services, and Microsoft Azure are probably the 3 biggest players in that area. If you learn to use one of them, this is a great plus for your resume. I added OpenShift here because sometimes companies, they don't want to run their software on the public cloud and they decide to implement their own version of the public cloud but indoors. Red Hat OpenShift can be used for that, which is nothing but a Kubernetes managed system created by Red Hat for companies. I added DevOps here because I think it's important to understand what it is and how that would impact your work. So DevOps literally means development operations. Usually we are software developers, but in the DevOps world, we are also responsible for understanding a little bit about the operations part, the infra, and how to run your application. Modern development teams, they work in a DevOps fashion because you want your team to be fully responsible for the application that you're working on. So you need to have someone that understands and can run your application in a Kubernetes cluster in Azure, for example. All right, with that said, let's move forward. Let's talk a little bit advanced testing. Contract testing is a way of making sure that different applications that need to communicate via REST APIs actually are doing what they promised each other. You see, imagine an application A and an application B. They're both REST application, let's call them microservices, and they will communicate via REST, sending requests one to each other. How do you make sure that both applications are gonna be loyal to the APIs that they agreed on? Contract testing. The Spring framework provides you with a great contract testing toolbox that will allow you to create your contracts. Another hot topic here is Gatling. or we could say JMeter as well. So Gatling and JMeter, they are tools that you will use to create performance, load, and stress testing on your application, which is very important. Before shipping an application to production, you need to know if the application can take it, to see if the application is stable in extreme scenarios. TDD BDD is my favorite topic, of course. I am a crazy fan of test-driven development. And basically what that means is that in the test-driven development, you will first write your unit tests and then you will come up with your production code. So that ensures that all of your code is covered by tests, and this will ensure a higher quality of your code. Not to mention that doing TDD is extremely fun and it feels like a game. When you write a test that doesn't work, then you create the code and then you see the test passed and you have the satisfaction of seeing all of those green check marks. Selenium is a tool that allows you to automate behavior on browsers. So when you have an application that has a front end, sometimes you want to test the front end and you want to automate some behavior, and you can use Selenium for that. It basically allows you to record operations being performed on a user interface such as in a browser. Alright guys, let's talk a little bit about Spring. So we're gonna discuss some advanced Spring topics. The first topic I have here is caching. So caching is a technique that allows you to store some data in memory on your application to avoid your application on doing expensive operations, such for example, database access or connecting to another system to get that data. If there is a lot of requests on your system for a certain kind of data, you don't want to be going to third parties to get that data from, because this is expensive. So instead, you take that data one time, you put it in a cache, and then you serve your clients with that data straight from the cache. So when we're talking about reactive web here, we're talking about servers that are non-blocking and they're using the reactive programming model. So Spring supports the reactive model out of the box. You can use the project reactor to implement your controllers in a reactive way. And it's slightly different from the traditional Spring programming model. And basically what this will allow in certain cases when a system is overloaded in requests, you might want to consider learning how to do reactive programming in order to have a system that can serve more requests. Alright, Spring AOP. So let's talk now a little bit about Spring AOP. So AOP here stands for Aspect Oriented Programming, and it's basically a way of taking things in the system that happens in a lot of different places and creating a layer of behavior around that. I know it's really hard to understand with me saying that, but let me give you an example. Imagine in your application you have a lot of REST endpoints, so basically controllers, and you want to log something when you call an endpoint, right? Imagine an application that has a lot of HTTP endpoints, and those HTTP endpoints are spread across different classes in different controllers. Bear with me for a little. Suppose you want to make a log every time a controller is accessed. You could use Spring Aspect-Oriented Programming to do that by defining an aspect that will intercept every request to every controller, and he's gonna do an operation there. Again, we have here Spring Messaging. We touched the topic here in messaging, but basically what that means here is that Spring provides you with a lot of tools and a lot of APIs that seamlessly integrate with all of those messaging systems. Spring Cloud is also a huge thing. It's basically the Spring way of working with the cloud, and it also has a lot of APIs and a lot of integration with all kinds of cloud providers, tools, and things related to the cloud, basically. Okay, let's go on and talk about some books. further reading. Let's see. Okay, I added here two books. One of them is one of my favorite books ever. It's Pragmatic Programmer. This is a really old book, I think from the 70s or something, but it's such a beautiful and even philosophical book about programming. I think if you read this book, you will be a better person, not just a programmer. So the Pragmatic Programmer is a book that's gonna touch all of the topics of the software development life cycle, and it's a really fun book to read. It has a lot of relevant information, and it will really make you a better programmer. The Clean Architecture book here, on the other hand, it's a book that will give you more information about creating good architectures for distributed systems and large scale applications, which is probably the stuff that you're going to be working as a senior Java developer. Last but not least, I want to talk to you guys about monitoring and logging, which are extremely important things that every large application has. Let's break it up in two here. The first part is Grafana and Prometheus. When we talk about monitoring, these two words often they come into place. You see, a running application is always generating a lot of metrics, such as CPU consumption, memory consumption, how many requests the server is handling, how many errors are being generated. So all of this metadata that an application is generating is exported out of the application via Prometheus. So Prometheus is a tool that allows to export all these metrics out of your application somewhere. Usually, this data is exported to a database, and you can view this in real time through different dashboards that are created using Grafana. So this is how these two technologies correlate. They allow you to really monitor your application in real time and see what's happening. You can also create alarms based on certain preconditions that will alert you when something is going wrong. Now let's talk a little bit about logging. It's very important to have logging in your system for the cases when things go wrong and you need to do an investigation. Imagine a client made a payment on your system, but the payment never arrived. How to track this? How to investigate that? You will do that via logging. The holy trinity here is Logstash, Kibana, and Elasticsearch. What happens is that modern applications, they're usually created in the form of microservices. Each microservice is producing its own logs. So you can imagine that a large application will have tons of logs. Each microservice is generating a lot of logs. All these logs, they need to be searchable, right, in a way. So that's how you're gonna do that. You're gonna use Logstash to actually collect all those logs and process them. You will use Kibana to search those logs. Basically, Kibana is a user interface that allows you to query those logs. And Elasticsearch is a mechanism behind Kibana that will allow you to actually search those logs, because it is a lot of data and you need to be efficient while searching things in that data. So these three tools together, they allow you to do this aggregation, logging, searching thing. So guys, we did it. We covered all of the topics. I know it is a lot of stuff, but all of this here is what makes a really good senior Java developer. I'm telling you, if you know half of this stuff, you are sure to get a job in the market, as long as you look for it and you apply to the jobs and you go through some interviews. With this knowledge right here, you will get a six-figure salary in no time.